Okay, we're still looking at theory for exercise 3.4, and we're looking at the use of De Moivre's theorem in solving equations and deducing any of these sort of trigonometric results, which involve sums and roots of equations. Okay, so remembering De Moivre's theorem, if z equals r, remember this is cis theta, so cos theta plus I sine theta is just cis theta. So if z equals r cis theta and n is an integer, then for the next row, z to the power of n equals r to the power of n cis n theta, or cos n theta plus I sine n theta. That is, in other words, we can write that r to the power of n cos n theta plus I sine n theta is, so if we now look at, so therefore this bit here is equal to r to the power of n, so this to the power of n, cos theta plus I sine theta to the power of n. In other words, here I've got if z equals r cos theta plus I sine theta, couldn't I just take powers of n on both of these sides as well? Z to the power of n would be all of this to the power of n, which is r to the power of n cos theta plus I sine theta also to the power of n. So, or you write it where you put the n theta. All right, so you're okay with that? If that equals that, then the left-hand side to the power of n equals the right-hand side to the power of n. That's what I've just done there. All right? But we know this is De Moivre's theorem, that z to the power of n is r to the power of n cis n theta, or cos n theta plus I sine n theta. That bit is De Moivre's theorem, the bit that I've asterisked. And this first line is just saying if z equals r cis theta, then z to the n is r cis theta, all to the power of n. But I haven't put that n in front of those. Got it? So, it says use De Moivre's theorem to express cos 3 theta in terms of cos theta and sine 3 theta in terms of sine theta. You know, in 3-unit extension, in 3-unit tree, you learn how to do that using sums and differences. You learn how to do that doing cos 2 theta plus theta, sine 2 theta plus theta. You'll end up with those cubed results and 4 cos cubed whatever. But you can also use De Moivre's theorem to also come up with the same result. Okay? So, we're just going to use this result here. But in this case, so I could just say that cos 3 theta plus I sine 3 theta. So I'm just going here. I'm just using this. So cos 3 theta plus I sine 3 theta, isn't that the same as cos 3 theta plus I sine 3 theta to the power of n? Sorry, cos theta plus I sine theta to the power of 3, sorry. So that's just using this result here. Basically, we've got that r is 1 in this case. Okay? So now we're going to, I'm just going to keep that over there. I'm now going to expand this using our binomial, you know, the binomial coefficients of cubed, a 1, 3, 3, 1 of Pascal's triangle. We good with that? We've got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So it would be highest power of cos, do you remember? Cos cubed theta plus, what's next? 3, cos squared theta times I sine theta, plus 3 again. Cos theta times I squared sine squared theta plus 1, or I cubed sine cubed theta. So now, just using I squared is negative 1. What do we got? Cos cubed theta plus, what do we got? Plus 3i cos squared theta sine theta. I squared is negative 1. Minus 3 cos theta sine squared theta. I squared is negative 1. Minus I sine cubed theta. So now we can equate real and imaginary parts. So the imaginary parts are underlined and the real parts are not underlined. So therefore, equating real and imaginary parts we have that cos 3 theta equals cos cubed theta minus 3 cos sine squared theta. And using our, remember we're trying to get this all in terms of cos theta, so we just replace our sine squared theta with 1 minus cos squared theta. So it's cos cubed theta minus 3 cos theta, 1 minus cos squared theta. I need to leave room over here, which is cos cubed theta minus, haven't we got 3 cos theta plus 4 cos cubed theta? No, plus 3 cos cubed theta, which I don't have room to write it, so I'm just going to put the 4 here. Are you okay with that? Because it's cos cubed theta minus 3 cos theta plus 3 cos cubed theta, which I just missed that line, which just gives me 4 cos cubed theta minus 3 cos theta. Now, equating the imaginary parts, sine 3 theta is, you don't have to put the i's in, of course, it's 3 cos squared theta sine theta minus sine cubed theta. I don't have to do anything with the sine cubed theta, just replacing cos squared theta with 1 minus sine squared. But I'll bring that sine theta to the front. So it's 3 sine theta, 1 minus sine squared theta minus sine cubed theta, which is 3 sine theta minus 3 sine cubed theta minus sine cubed theta. That would be 3 sine theta minus 4 sine cubed theta. So that's just part A. Now says use the result to solve this equation. So use the results from up there to solve the equation 8x cubed minus 6x plus 1 equals 0. So looking at either of these two, the most appropriate one to use would be the first one, because this 8x cubed sort of double that, and this minus 6x is double the minus 3x. So we're just going to go, let x equal cos theta. Therefore, our equation becomes 8 cos cubed theta minus 6 cos theta plus 1 equals 0. I'm going to take the one, I'm going to rearrange the equation. So I've got 8 cos cubed theta minus 6 cos theta equals negative 1. And if I actually divide both sides of the equation by 2, I get 4 cos cubed theta minus 3 cos theta equals negative a half. Now, what do you think I should replace that 4 cos cubed theta minus 3 cos theta with? Yeah, just replace it with cos 3 theta. So therefore, using your bit from part 1, so using your bit from part A, we can say therefore cos of 3 theta equals negative a half. And now this just becomes, we're not asked to solve this in any particular domain, so we need to give the general solution. Cos of what is a half? Cos of 60. Okay, remember it's negative, so we've got the, we're not talking quadrants 1 and 4, we're talking quadrant 2. Has to be quadrant 2, not 3. Remember, if you're doing general solution where cos is of something is negative, the first negative quadrant for cos, which gives you the smallest value, is quadrant 2. So we go, therefore 3 theta equals, now I'm going to write down what those solutions are. Remember, we're looking at quadrant 2. Acute angle is 60, right? So, where am I going to put? I might just put a little diagram somewhere. Okay, pi on 3 there. So what do we got? So isn't that 2? It's 2 pi on 3. The next one would be, I'm not going to do general solution, I'm just doing the solutions. I could do general solution and put k is 0, k is 1, k is 2, or I can just start listing them out, okay? In the example you've got here, they're just listing them out. Okay, notice this is a cubic equation. I'm going to list some solutions, but I only need 3 solutions, but I do list more than 3, and then you'll start noticing that some of them are duplicates of others. So we've got 2 pi on 3. What would this next solution be? It'd be pi on 3 plus pi plus pi on 3 is 4 pi on 3. So once you've gone around once and you've got 2 pi, you've got another 2 pi on 3. So that's 2 2/3, 8 pi on 3. Just look what happened from 2 pi on 3 to 4 pi on 3. So the next one is another, would be 10 pi on 3, etc. Now, so therefore, that's what 3 theta is. And so therefore, theta is dividing by 3, 2 pi on 9, 4 pi on 9, 8 pi on 9, 10 pi on 9, but etc. But, now that's just what theta is, but we have to look at the cos of all these angles, so some of these are going to be the same. But your solutions are x equals cos theta, right? But x equals cos theta, and so what we've got is, therefore x is cos 2 pi on 9. Now where's that? That's quadrant 1, isn't it? Yeah. Yeah. Cos of 4 pi on 9, that's still quadrant 1. Cos 8 pi on 9, cos 10 pi on 9, etc. Comma, dot, 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 dot. So I've got comma, dot, 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 dot. Now, remember a cubic equation only has 3 roots, okay? So there are only 3 roots or solutions to this. So we just need to see which ones are the double ups, okay? One of them will be a double up. Remember that cos of 10 pi on 9 is minus cos pi on 9. Just going to have a quick sketch of where these are. There's 2 pi on 9, 4 pi on 9, 8 pi on 9. Isn't that down here? No, it's here. 8 ninths. 10 pi on 9 is here. But, so, yeah? Yeah. But you're not allowed, your principal argument only goes from 0 to pi or from 0 to negative pi. So for a start, you would never call that, okay? So we'll only have 3 roots, but notice, all right, here is your first solution, quadrant 1 positive, quadrant 2 positive. These 2 solutions here in quadrants 2 and 3 are both negative, and you've got the same acute angle in there. The acute angle in here is pi on 9, and so is this one. So therefore, those 2 are the ones that are equal. We can say that but cos of 8 pi on 9 is equal to negative cos of pi on 9. Remember, we look at the acute angle. And also, cos of 10 pi on 9 is also equal to negative cos pi on 9. So therefore, we're going to give our answers as x is cos of 2 pi on 9, cos of 4 pi on 9, and we're going to give negative cos, negative cos of pi on 9, not cos of negative pi on 9. I know I've put here where these particular angles are. Cos of 2 pi on 9 is just cos of 40 degrees if you convert that to degrees. So that might be this one. It's positive. Cos of 4 pi on 9 is like cos 80. So they're going to give different answers. Cos of 8 pi on 9 is actually cos of 160. Okay? That's the same as negative cos 20 or negative cos pi on 9. Okay? And cos of 10 pi on 9 is cos of 200, which is also negative cos 20. And that's what we're saying here. But cos of 8 pi on 9 is negative. In other words, 9 pi on 9 is all the way up to pi. This acute angle here is pi on 9. And remember, to represent any angle in quadrants 2, 3, 4, you write it as plus or minus the cos of the acute angle. And it's negative because quadrant 2 cos is negative. And here in quadrant 3 it's negative. But they've both got the pi on 9 in there. Okay? So therefore these 2 answers are the same. But it's, you know, it's easier, let's say if it happened to be an exact value, to equate this angle like that, negative cos pi on 9. We know it's not an exact value, but if it was. Right? Hence deduce that cos of 2 pi on 9 plus cos of 4 pi on 9 equals cos pi on 9. Now this is sum of roots. Even though it doesn't look like it, it is sum of roots because This last root is negative. When you take that negative over, it becomes positive. So basically what they're doing here is sum of roots one at a time. All right, so let's go. And remember, it relates to the original equation, but the original equation is 8x cubed plus 0x squared minus 6x plus 1 equals 0. Be careful, b is 0. So therefore, we really want to do sum of roots one at a time is cos of 2 pi on 9 plus cos of 4 pi on 9 minus cos of pi on 9 minus cos of 4 pi on 9 equals negative b on a, which is negative 0 over 8. In other words, cos of 2 pi on 9 plus cos of 4 pi on 9 equals, whoopsie, so sorry, just fixing that up, cos 2 pi on 9 plus cos 4 pi on 9 minus cos pi on 9, that's adding the three roots from part B together, equals negative b on a, which is negative 0 on 8, which is just 0, and now just rearranging this minus cos pi on 9 over to the other side becomes cos pi on 9. So therefore we've deduced that second result, the first result, sorry. Now we need to deduce the next result. Even though these aren't causes, they're just secs, which is 1 on cos. So what does it appear? What appears to be happening here? Adding, subtracting, multiplying, how many? We're multiplying three roots. We're multiplying the three roots. So you multiply the three roots that you've got and then do some rearranging. So now we want to do for part 2, therefore the product of roots, 3 at a time, is cos of 2 pi on 9 times cos of 4 pi on 9 times negative cos of pi on 9 is equal to negative d on a, which is negative, a, b, c, d, negative 1 on 8. So remember, I've got a negative on this side and a negative on that side, multiplying through by negative 1. What we're really just doing is doing the reciprocal. So we can just take reciprocals of both sides and multiply by negative 1. I mean, you can multiply by negative 1 first. So therefore, cos of pi on 9 times cos of 2 pi on 9 times the cos of 4 pi on 9 equals 1/8. And now taking reciprocals of both sides. We just get the result that we want, okay? Therefore, sec of pi on 9 times sec of 2 pi on 9 times sec of 4 pi on 9 equals 8. Now, because it does say show that, deduce that, you need to say all this, taking reciprocals of both sides. I would even say here multiplying through by negative 1. If they just said come up with an expression for that and they don't give you the 8, then do what you want. But if they say deduce that, show that, you need to explain every single step. Okay?